Most Java developers reach for ArrayList by default, but when should you actually choose LinkedList instead? The answer lies in understanding how these data structures work under the hood. ArrayList uses a dynamic array internally, giving you constant time O of 1 access to any element by index. Just jump directly to that position in memory. LinkedList, on the other hand, is a chain of nodes where each element points to the next. To access element 50, you have to traverse through all 49 elements before it. That's O of n time complexity. When you need random access, ArrayList wins every time. But here's where LinkedList shines. Inserting or deleting elements in the middle of an ArrayList requires shifting all subsequent elements over, which is O of n. LinkedList just rewires a couple of pointers, making it O of 1 for middle insertions and deletions. However, this advantage only matters if you're frequently modifying the middle of your list. And you still need O of n time just to find the insertion point. ArrayList stores elements in contiguous memory, which means better cache locality and memory efficiency. Your CPU can prefetch data, making iteration blazingly fast. LinkedList scatters nodes across the heap, each with extra pointer overhead. This means more memory per element and cache misses during traversal. So when should you actually use ArrayList? Almost always. It's faster for iteration, uses less memory, and provides instant access by index. Reserve LinkedList for rare cases where you're doing heavy middle insertions and deletions and don't need random access. Bottom line, ArrayList is your default choice for 95% of use cases. Master these trade-offs and you'll design better data structures in your interviews and production code. Practice more questions like this one. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.